They want us to list the asymptotes. There should be a handout in Canvas under modules that overview all the asymptotes. But let's start with the vertical asymptotes. The vertical asymptotes occur where it's undefined. So if we set the denominator equal to 0, we could either factor this, or for this one, we could move 25 over, take the square root of both sides. But remember, if we take the square root of both sides, we have to include plus or minus. That's the only time we include plus or minus for a square root, is if we take the square root of both sides, not just one side. So if the denominator is 0, if we can plug a number into our function and it makes the bottom 0 but the top not 0, it is a vertical asymptote. What do I mean by that? If it makes a 0 on top and a 0 on bottom, that's not a vertical asymptote. That is undefined, but that is actually going to be something other than a vertical asymptote. So for this one, that doesn't happen. If we plug a 5 in, f of 5 gives us 10 on top, 0 on bottom. If we plug negative 5 in, we get negative 10 on top, 0 on bottom. So both of those are vertical asymptotes. Now, what other kind of asymptotes could we have? So when we have a rational function, we typically have vertical asymptotes, but we could also have horizontal or oblique, or sometimes you hear obliques called slants. The way we determine that is by the degree of the top and the bottom. The degree on top is 1. The degree on bottom is 2. Remember, we determine the degree based on the largest exponent. And the rule states that if the degree on bottom is bigger, we have a horizontal asymptote at the x-axis at y equals 0. That's only if the degree of the denominator is bigger. So for this one, we have 3 asymptotes. We have the horizontal at y equals 0. We have a vertical at x equals 5, and a vertical at x equals negative 5. So here they ask us to determine the asymptotes. So let's look at the bottom first. If the denominator is 0, we could have vertical asymptotes. So we could either factor this, or we could add 4 to both sides, and then take the square root of both sides. So square root of both sides, we have to do plus and minus the square root. Notice neither one of those are going to make the numerator 0. If we plug a 2 in, we get 56 over 0, so that's a vertical asymptote. If we plug a negative 2 in, we get negative 56 over 0. So as long as the bottom is 0 and the top is not, it is a vertical asymptote. And again, for the other type of asymptotes, we have to look at the degrees. The degree on top is 3. The degree on bottom is 2. So the previous one, if the degree on bottom was bigger, we had a horizontal asymptote at y equals 0. If the degree on top is bigger, by exactly 1, we have an oblique or a slant asymptote. And the way we determine the equation of that asymptote is it's y equals the quotient. We need the quotient if we divide this function, and that will tell us the equation of that slant asymptote. So 7x cubed is our divisee. We're dividing by x squared minus 4. Now, if what was out front was linear, we would just use synthetic division. But since it's not, we have to use long division. So we have to be careful. We have to put zeros for any missing terms. So no x squareds, no x's, no constants. And out front, we have no x's to the first. So no x's minus 4. Whoops. Minus 4. So really it's just 7x cubed divided by x squared minus 4. But we put placeholders so that our columns would line up. So we do this first term divided by that first term. So 7x cubed divided by x squared. That makes 7x. Then we take that and we multiply it times everything out front. So 7x times x squared is 7x cubed. 7x times no x's, well 7 times 0 is 0, x squared, and 7x times negative 4, so minus 28x. The top one minus the bottom one, so 7 minus 7 is 0. 0 minus 0 is 0. And if we do 0 minus negative 28, 0 minus a negative is really a plus, so that's 28x plus 0. Now, we do have more terms down here, but notice the leading term out here is bigger. It's a larger degree. So there's no dividing left to do. We only divide if these are of equal degree or if this one is bigger. So 7x is our quotient. So y equals 7x is our oblique asymptote. And then our vertical asymptotes are plus and minus 2. This one asks us for the vertical asymptotes. So let's factor the denominator. First of all, notice that all three terms have an x, so we can factor out an x. That leaves us 5x squared minus x minus 22. That's how we factor the denominator to begin with. And then we try to see if that will factor some more. So we have an x out front. To get a 5x squared, we would need a 5x and an x. And then 22 is either 1 times 22 or 2 times 11. So let's do it. 2 here and 11 here. And if we need a minus 1 in the middle, then that would be minus and plus. Notice that's 5x squared. That's minus 22. And the middle term comes from the outer product and the inner product. So notice that's negative 1x. So that's how the denominator factors. So this is going to be undefined anytime the denominator is 0. So if we have a product, it's where each factor equals 0. So it's undefined at x equals 0. If we set this one equal to 0, 5x minus 11 equals 0, we would add 11 to both sides and divide by 5. So that would be the second thing that makes the bottom 0. And then if we set the last one equal to 0, we would get negative 2. Oops. X equals negative 2. So we got 3 values that make the bottom 0. But notice one of these. If we put a 0 into our function, we're going to get a 0 on top and a 0 on bottom. So if it's 0 on top and bottom, then that's not a vertical asymptote. It is undefined there. So if we were describing the domain, we could not use any of those three numbers because all of those would make the bottom 0. But if we get 0 on top, then that's not a vertical asymptote. It's only a vertical asymptote if we get 0 on bottom and not a 0 on top. So like if we plug in a -2, we would get -8 on top, 0 on bottom. So since that's not 0 on top, that one is a vertical asymptote. Same thing with the 11/5. If we put in 11/5, we would get 0 on bottom, and we would get whatever 11/5 cubed is on top. It's not 0, so that's a vertical asymptote also. So in my handout in Canvas, I say that it's a vertical asymptote if the bottom is 0 and the top is not. Sometimes they describe it and say it's a vertical asymptote if the fraction is relatively prime, a fancy way of saying it's reduced, and then the bottom equals 0. Notice on this one, we have a factor of x in common. We have an x down here and a factor of x on top. Once we reduce it, the only things left to make it undefined are 11/5 and -2. But instead of having to worry about can it be reduced, is it relatively prime, all of that, I just like to find out where is it undefined, and then does it make the top 0 also. So for the next one, they ask us for the domain, the x and y intercepts, and the graph. So the domain, if we look at it, x cannot be 0. We're not allowed to divide by 0, so x can't be 0. So the domain is everything else. It's everything below 0 and everything above 0. If we look at the x and the y-intercepts, the x-intercepts occur when our function is equal to 0. Notice if we multiply both sides by x, we get -7 on the left, 0 on the right, which can't happen. Which means for this one, there are no x-intercepts. Remember, x-intercepts occur where y equals 0. Well, y can't be 0, or our function can't be 0 here. So for y-intercepts occur where x is 0. Well, if we've already determined x can't be 0, so there are no y-intercepts either. On the test, I'm not going to focus so much on x and y-intercepts, but just remember x-intercepts occur where y is 0. Y-intercepts occur where x is 0. So for x-intercepts, set your function equal to 0. For y-intercepts, plug a 0 in for x. But neither one of those can happen for this one. So let's graph it. So what we're going to do is we're going to begin by using our asymptote. So where are our asymptotes? Well, this one, the denominator is 0 when x is 0. That's our vertical asymptote. Well, do we have any other asymptotes? If our function is -7 over x, the degree on top is 0. Remember, the degree is the largest power of x. Well, on bottom we have x to the first. On top, we have no x's, so the degree on top is 0. So our rule is if the degree on bottom is bigger, our asymptote is horizontal at y equals 0. We have a horizontal asymptote at y equals 0. So two asymptotes. Y equals 0 is a horizontal asymptote. X equals 0 is a vertical asymptote. So then we just need to figure out, well, where is our graph going to be? So I often describe this as a pasture. And in this pasture or in this fence, we have a cow, or you could say a dog. And often what happens in pastures is dogs or cattle like to follow the fence to see if they could get out, or so they could eat grass on the other side of the fence. So you'll see a trail close to the fence going each direction. Could be up there, it could be down here, it could be up here, it could be down here. So we have to inspect and find out which pastures are our cows in. So we want to see when we pick x's on this side of the asymptote, where is our cow? Is it up here or down here? And then when we pick x's on this side of the asymptote, are we up here or are we down there? So we can simply do that by plugging in. On the left side, we could use an x value like -1. So if we take our function and plug in a -1, we get 7. So when x is -1, we have a point up here at 7. So that tells us which of the two pastures our cow's in. It's in the top one. So it's going to follow the fence that way, and when we get close to the corner, it's going to follow the fence this way. And they're going to follow the fences as far as they go. Now on the right side of the vertical asymptote, we could use a value like +1. So if we plug in a +1, we get -7. So when x is +1, we have a point down here. When x is 1, f of 1 is -7. So our cow is in this pasture down here. And it's just going to follow the fence. Follow the fence. So the fences are just guidelines for our graph to follow. All right, if we take a look at this one, let's notice that our denominator here factors to x minus 7, x plus 5. So x cannot be 7, and x cannot be -5. That's what makes it undefined. Notice both of those are going to be vertical asymptotes, because for either one of those, if we plug them in to the function f, they're going to make the bottom 0, but the top is some other number, something that's not 0. If we plug a 7 in, we get 2 on top. If we plug a -5 in, we get -10 on top. So anything else over 0 is a vertical asymptote. If we look farther, our degree on top is 1. Our degree on bottom is 2. Again, that comes from the exponents, the largest exponents. The degree on bottom is bigger, so we have a horizontal asymptote at y equals 0. So if the bottom degree is bigger, y equals 0 is our horizontal asymptote. So let's graph this. Make this a little larger. So y equals 0 is our horizontal asymptote. And then -5 and 7. There's one vertical, and there's one vertical. So we have to check several points on this one. When we have vertical asymptotes, we need to find out on each side of the vertical asymptote what's happening. Are we going towards positive infinity, or are we going towards negative infinity? Then on this other side, are we going up or down? And then our other vertical asymptote, are we going up or down, up or down? And the way we figure that out is with test points. So if we plug in, let's say, -6, y -6, -5 is a vertical asymptote. So let's pick something just to the left of -5, so -6. And you can do this with your calculator. If we plug a -6 in, we're going to get -11 on top. On bottom, we would get, let's see, -13 times -1. I'm plugging it into the factored version of the bottom. So that would be 11 over 13. That's positive. So when x is -6, we're almost up to 1. Not quite, but almost. So most likely we are in this pasture. We are there. Now let's check the other side of that vertical fence. So let's plug in a -4. So if we plug a -4 in to our function, -4 minus 5 makes a -9 on top. If we plug a -4 in on bottom, we get -4 minus 7, so -11. -4 plus 5 is 1, so that gives us -9 over a -11, which is positive 9 over 11. Negative on top, negative on bottom, cancel. So 9/11. So makes me think I may have put the wrong sign in on the other one. So that's here. So we're doing this. So if I go back to -6, I got in a hurry. If we put a -6 in, -6, we got a -11 on top, a -13 here, -1 there. So that when we put a -6 in, we had two negatives on bottom make a positive, so we actually had -11 over 13. Sorry about that. So we got to fix this. When x is -6, we were at -11 over 13, not positive. So depending on where our test point falls, that determines which little quadrant we're in. When we plugged a -4 in, we got here. So we were above the horizontal, which made us think we were going up. Now we have to test this other one. So if we test to the left, let's try a 6. If we plug in a +6, let's see what we get. Maybe I won't mess the signs up here. If we put in a +6, we get a +1 on top, 6 minus 7, so a -1 on bottom, times 11, so positive over negative, so that's -1 over 11. So at 6, we're at -1 over 11, so here, which makes us think that we're probably going to do this. Probably going to be doing that. You might say, well, we crossed the asymptote. I didn't think you could cross asymptotes. It's okay to cross a horizontal asymptote. it's not okay to cross a vertical asymptote. Horizontal asymptotes are not undefined, but vertical asymptotes are. So horizontal asymptotes, they can be touched. We just can't touch the vertical ones. So let's see what's going on the other side of that vertical. So let's plug in an 8. If we plug in an 8, we get a 3 on top. We get 1 times 13 on bottom. That's positive over positive, so positive 3/13. So that's 8, and then up 3/13. So it looks like we're going to be going this way. We're in this region because our point is here, so we're going to follow our boundaries like that. So by testing points on each side of the vertical asymptote, we were able to see on the left side, since we were negative, it looked like we were going down. On the right side, we were positive, so it looked like we were going up. All right. Let's look at one more and determine the asymptotes. And let's just get the horizontal or oblique. So in this one, the degree on top is 1, the degree on bottom is 1, because those are our largest powers. So our rule says if those degrees are the same, if those degrees match, then we have a horizontal asymptote, and y equals the leading coefficient divided by the leading coefficient is where our horizontal asymptote is. So we never have both the horizontal and a slant. We have one or the other. So if the degree on top and bottom are the same, we take this ratio. If the degree on bottom is bigger, y equals 0 is the horizontal. If the degree on top is bigger by 1, it's a slant asymptote.